It's one thing to detect a face, but recognizing Maria, Jason, and all your favorite people from just a few pictures, that's a whole new level of skill. And that's exactly what we'll do today. We will teach our computer to recognize specific faces in live camera feeds, using your own photos, your own code, and without sending anything to the cloud or spending any money. All you need is OpenCV, YOLO, and about 20 pictures, and boom! You got yourself a smart security system. So if you watched my recent face detection video, then you already know the basics. If you haven't, don't worry. I'll explain everything here as well, so homework is cancelled. By the end of this video, your camera will know exactly who you're hanging out with, which is a little creepy, so we will make sure we do it safely. Finally, this video is brought to you by HubSpot. We will talk about them more shortly. So if you're ready, let's roll. Let's start with the photos that our system will learn. You can, of course, download my photos from GitHub, but for this project, it is better to use your own photos. Photos of yourself and anyone who can physically be with you when you test this system. So yeah, you can play one of my videos on your phone and show it to the camera, but it's much better to have somebody with you in the same room. And it's a pretty cool project, so I'm sure they'll enjoy it. Also, very important to mention, since everything, including the models, lives on your computer, you're not sharing these photos with anyone. You're not uploading them to some cloud provider or some, third-party app. Great, so at the root of our project, we have a folder named Faces. And inside it, every person gets their own folder where we dump a whole bunch of pictures. I have mine, there you go, and I have Mario's, who will join me when it's time to do the testing. And the idea is the more folders we add over here, then the more faces our system will recognize. Now, we do have some rules. Each picture can only have one face, and it must belong to the right person. 2, make sure the photos reflect what the camera is going to see. So if the camera is pointing at my green screen setup with controlled lighting, then that's the type of photos we provide. If it's a security camera that moves from side to side, running at different times of day under different weather conditions, then you will need a much bigger gallery with a lot more variety. And 3, we don't really care about the size of the face or how much of the body appears in the photo, because the first thing we'll do in our code is find the face and crop it automatically. So when I say just dump a bunch of photos there, I actually mean it. And beautiful. Once our folders are ready, we will move on with training. And we will do so with the detection environment that we've set up in the previous video, running on GPU in my case. I left all the instructions in the pinned comment so you can set it up exactly as me. If you don't have a CUDA compatible GPU, you can still set it up, it will still work, it's just going to be a little bit slower. So let's create a new Jupyter Notebook at the root of our project, right besides our Faces folder. And again, check out the pinned comment if you don't know how. This is very easy. I've also included all the imports in the description. You can just copy them and paste them like so. On my end, I will also run them as a separate cell, just so I don't have to worry about it later. Now, to keep things simple, we are going to start with training on only one person. Once we get that to work, we will then expand it to multiple people. So first, we need the folder where our photos live. In my case, folder equals faces/Maria. And then we will list all the files in this folder with os.list_dir, to which we will pass our folder. And this will return all our images back. Great, so now let's assign it to files. And then let's load each of those files as an image with OpenCV, which is the computer vision library we are using in this project. So down below, for file in files, we will load them with cv2 im read, as in image read, passing it the path to each file, which is folder/file. And this one we can assign to photo. How do we know if it worked? Well, we will just copy this absolutely horrific line of code from the description. Okay, I apologize in advance. We will paste it outside of the for loop. And if everything worked properly, then it will display the very last image we've loaded. This one should match the last image you have in your gallery. So if we open it, yep, I have the exact same stupid face. Perfect. So now that all our images are loaded, let's find the face in them and let's crop it. Since we already know how to do it, I will quickly explain it to the new folks. We simply download a model named YOLO version 8 medium face. We do it from GitHub. The link is in the pinned comment. All you do is scroll down and you click it. You then save this model right next to our notebook, right over here, and we load it into our code. Then we pass our photos into this model one at a time. It automatically finds faces in them and it returns their exact location along with some other stuff. Now, so far, we only cared about processing the original image or drawing a blue box around faces and then displaying the results. So if we now quickly display this processed image with our horrific command from earlier, we then see a blue box right on top of the original photo that says face. That's exactly what we did in the previous video. For this workflow, we don't really need the full image. We only need whatever lives inside this blue box. Okay, so instead of plotting the processed image, let's quickly see what else we can do. So right above, we will just comment out our last line of code. And instead of it, okay, we will quickly print the face result in the index of 0, just to see what else lives inside. Okay, if we scroll up, the first thing we see is exactly what we're looking for, boxes. So let's add dot boxes to the very end of our expression to take another dive, okay, and see what else is there. And now we get a whole bunch of settings back, and it's kind of hard to tell what they actually mean. The only setting I'm comfortable with is this X, Y, X, Y, because it seems to be like a bunch of coordinates. So let's quickly add it to the end of our expression, right after boxes, and let's give it another print. And okay, we get 4 numbers back. And these two, they must be X1 and X2, the left and the right. And these two must be Y1 and Y2, which is the top and bottom. And from these 4 points, we actually draw our box. Great. So this means we can unpack this expression, okay, into left, top, right, and bottom. Hopefully I got the order right. Okay, this is X1, X2, Y1, Y2. Perfect. But we actually need to be careful here because as you can see, we're not getting one set of coordinates back. This is a nested structure. And that's because there could be a few faces in each photo. So even though we know for sure that our photos only have one face, our code is not aware of it. It keeps looking for multiple faces. So to ignore it, we will just focus on the first, okay, and only item of this structure. And only now our expression unpacks properly. Okay, so let's give it a quick indent because it happens inside the for loop and not outside of it. And then once we have these lovely coordinates, we can then slice our photo accordingly. So we will type photo in the index of top to bottom, left to right. And then we will assign this new expression to face because that's exactly what we get when we slice our photo to this box. But there's actually one more thing to be careful here, because even if we focus on the first item of the list, this item stores fractions, okay? It doesn't store whole numbers. So when we are trying to slice a photo that's made out of pixels, there is no such thing as 233.6 pixels. There's only 233 and 234. There's nothing in between. So before we are even attempting to slice, we need to convert these floating point numbers into integers. For this, we will add the int method at the very end of our long coordinates expression. Hopefully my head doesn't block it. And now if everything worked properly, okay, when we try to display our face in our horrific command, then it should work. Okay, fingers crossed. Let's give it a quick run. And bam, we see my stupid face returned back to us. But there's one more thing left to do, and it's storing these faces. Because right now we are catching them, but we don't do anything with those faces. They just go nowhere. So then right above our for loop, we will create an empty list called faces. And then at the bottom of our for loop, oh, what did I do? I accidentally ran this cell. Sorry, guys. Okay. At the bottom of our for loop, we will append each of our faces into this empty list with faces.append, to which we will pass each individual face. And now to make sure it worked, instead of the very last face, let's go ahead and display faces in the index of 0, which is the very first face. Let's give it another run. And okay, we no longer get the stupid face, but a much more refined one. Yay, we can officially move on. Now, so far, our AI model only has one job: find the face. But the more complicated our project gets, and the more tasks we give it, then the less we actually want to hold its hand at every step of the process. Just figure it out and call me when you're done. That's exactly what AI agents are here for. And if you've been wondering which ones are actually worth trying, I think you will really enjoy HubSpot's free AI agents cheat sheet. It compares 7 different AI agent tools, shows you what each of them is actually good for, how easy it is to set them up, what it costs, and if it fits the kind of work you want to automate. And each tool comes with copy and paste prompts for real workflows, so you can just grab one and go. There's also a very important tip here that I want to highlight. Start with the simplest version of your task and get one thing working well before adding complexity, which is exactly what we're doing in this tutorial. So check out the full guide using the link in the description. It is completely free. Thanks so much to HubSpot for sponsoring this video. And now let's teach our model who these faces actually belong to. For this, we will load a face recognizer that is already built into OpenCV. Just copy this command from the description, otherwise it's a lot of typing. It is called the local binary pattern histogram face recognizer, and we will feed our cropped faces into it. You will need to pip install OpenCV contrib Python, so go ahead and collapse your notebook, install it from the terminal, and only then go back. If you don't run it, then you will get an error. Now, for this type of face recognizer, we need our images in grayscale and matching in size. So right before we append them into our list, we will go ahead and call cv2.cvt color, passing it our colorful face and converting it with cv2.color _BGR to gray. We can then reassign it back to face, overriding the original photo with a gray version. Additionally, right below, we will cv2.resize, passing it our gray face, and then resizing it into a size of 200 pixels by 200 pixels. And then once again, we will assign it back to face. We can now give it another print below. Just make sure you remove this horrific part, okay, from our image display command, because now we don't need to worry about color dimensions. We only have one because the image is gray. Okay, so now when we give this cell a run, beautiful. That's exactly what our recognizer expects. To us, it looks a bit distorted. It's kind of wide, okay? But for computers, this is perfect. And I'm so sorry to interrupt you guys, but if you enjoy this video and if you find it helpful, please consider clicking on the like button, the hype button, or leaving me a very nice comment. Anything that will help the algorithm will be highly appreciated. And now let's go back to the video. So now that our faces are processed and then appended in a list of faces, we can now feed them into our face recognizer. So let's quickly copy the name of our model, and then right below, right after our for loop ends, we will go ahead and call face recognizer.train. And we will, of course, pass it our list of faces. But that's not all. We can't just send our models a bunch of faces without telling it who these faces belong to. So right above our empty list, at least initially, of faces, we will need an empty list of labels. And these labels, they will tell our model that this face belongs to Maria and that face belongs to Mario. So both of these lists, they have to be at a perfect orderly sequence. Now, to make it happen, in the very end of our for loop, right after we append each of our faces, we will also append each of our labels. We will do so with labels.append, and we will pass it the name of the person that this face belongs to. But here's the thing. We can't just use an actual name. Our model doesn't know any letters. It only knows numbers. So instead of saying that all those photos belong to Maria, we will say that all those photos belong to class 0. Okay? That way, class 0 always represents Maria, and then later on, when we are dealing with multiple people, then class 1 will always represent Mario, class 2 will always represent Neo, and so on and so on. Great. So then in our training command, right next to our faces, we will also include our labels. And then finally, once the training is complete, we will just save the results with face recognizer.write. Okay, and we will call our special results file face recognizer.yaml. Great. So now let's give this cell a quick run. And we get an error. And that's because our labels are not a NumPy array. Okay, well, that's an easy fix. So right at the top of our code, let's do it in the first cell, we will import NumPy as NP. And after we run it, then back in our train function, we will wrap our labels in a NumPy array. Like so. And now when we rerun this cell, everything should work like a charm. Let's open our file system. And boom, our training is officially complete. And we have a new face recognizer YAML in our file system. Yay! Okay, so how do we take this code and get it to recognize multiple people and not just Maria? I slightly rearranged the variable so I can explain it better, but it's the exact same code from earlier. So right now, our code only knows about one folder. And since all the photos in this folder belong to Maria, we gave all of them the exact same label of 0. But now we want to add Mario and set his label to 1. So let's try to hit 2 birds with 1 stone. Let's create, a dictionary of folders where we will set the key of 0 to store faces/Maria and the key of 1 to store faces/Mario. So now we know where to get those photos and who they belong to. And then right below, we will load all these photos with for label folder in folders.items. That's how we iterate over a dictionary. The first time with label 0 and folder faces/Maria, and the second time with label 1 and the folder of faces/Mario. Okay, so that way, inside this new loop, we can use the exact same commands to find all the files as well as anything that comes after without any changes. So the only thing we do is indent our files and our old for loop, with tab. And now we are nesting it inside this new loop that we iterate over a dictionary. We still use the same variables, files and folder, even though they represent different people one at a time. So then finally, at the very end of the loop, instead of appending 0 time and time again, 0 only represents Maria, we will now append the actual label that we pull directly from our dictionary, either 0 or 1, depending on the actual person. And that's it. If we now rerun this code, let's do it. our model will now recognize two faces and not just one. If we pull out our file system and we wait until our face recognizer refreshes. Okay, there you go. 4 seconds ago, we saved a fresh version with two classes and not just one. Now we can, of course, automate it even further, especially if we're dealing with tens of people. Okay, so check out my GitHub if you want to know how. Okay, so how do we take what our face recognizer learned and we plug it into a camera feed? Now, we already know how to detect a face in a video. We did it together in the previous tutorial. We simply capture the feed from our the feed from our camera. It's usually our webcam or some kind of a USB camera. In my case, I'm grabbing the footage from my DJI Osmo Pocket that lives at index 2 on my computer. On your computer, it could live at index 0 or 1 or some other number. So just play with these numbers and you will find it, eventually. Then we open a video stream that keeps playing until we press the X key on our keyboard. And then we take each frame, from the video stream, and we then feed it into our face model. Okay, so we pull it from the video and we pass it through the model, getting processed feed in return. Okay, and then we display this processed stream, this processed feed, with a blue box, around a face. So if we give this code a quick run, this is exactly where our previous video ended. Face successfully detected, but this is just a face. Now, to recognize who this face belongs to, as you may guess, we will need our OpenCV face recognizer once again. So let's quickly collapse it. And let's copy our face recognizer from the previous cell. Okay. And we will initialize it right below our face model. But this is not the model we trained. If we want to load the version that is already familiar with Maria and Mario, we will simply type, face recognizer.read, and we will pass it the name of the file that we just saved with our results, face recognizer.yaml. And now this is the model we trained. So what exactly are we supposed to do with this model? Well, similar to what we've done earlier, we will take the coordinates of this face box, from earlier, we will crop them, grade them out, and resize them. But instead of using it for training, we will use them for prediction. Meaning, the model will take everything it learned and it will guess who this new anonymous face belongs to. So we are no longer telling the model that this face belongs to Maria. We now get the model to tell it to us. Okay? For this, we'll go ahead and copy all our transformation commands from earlier, starting from the coordinates and ending with the resizing. We will paste them right before we show our feed. Fixing the indentation. And we will rename photo to frame, because right now we are no longer dealing with a folder of photos. This is no longer our training stage, but we are dealing with a real stream coming from the camera through this very complex pipeline, and then we are cropping any kind of face from this stream. So after we detect the face box, after we crop it, after we recolor it, and after we resize it, we can then officially call face recognizer.predict, passing it our face. Basically asking the model, who is this? Now, the cool part is that the model doesn't just tell us who it is. It also tells us how closely this face matches the person. So when we unpack our prediction, it actually gives us back the predicted label. So let's call it pred label, as well as the distance. So if the distance is small, then the face looks exactly like the person. If the distance is big, then the person is not doing too well. He has seen better days, But how do we actually know if it worked? Well, we can just put this predicted label on top of our camera feed, right? So at the bottom, of our for loop, we will go ahead and add some text with cv2.put text. And then we will fill in all these placeholders with actual values. Let me just quickly separate them into a few lines because my head is gonna, cover a lot of them. Now, the image we are putting the text on is, of course, our processed feed, the one that we display later. The text we want to put on this feed is our pred label, okay, the one we got from the model, the best guess that the model made, and we will wrap it in a string, okay, because as I mentioned earlier, the model is dealing with numbers, not letters. We will then place it on the left side of our blue box, okay, so left, and we will also place it at the bottom of our blue box, actually slightly below it, so bottom plus 20 pixels. Okay, and then we will use font number 0. We will use the font size of 0.8, the color of white, so 255 by 255 by 255. Okay, and finally the thickness of 2. And then hopefully when we give this cell a quick run, okay, no, hope is gone. Okay, we get an error, something that has to do with the origin. Now, if you're a graph enthusiast, which I am sure many of you are, okay, you've probably heard of the origin of the coordinate system, 0.00, okay? So this label probably tells us that it has to do with coordinates, okay? The left and bottom coordinates that already gave us a hard time before. Okay, since we previously converted them to integer, let's try to do it again. Okay, integer and integer. Okay, and hopefully this solves it. Let's give it another run. And boom, we now see label 0 right under my chin. And we already know it means Maria. But we are not done yet. Because if now I ask Mario to join me, okay, Mario, we are not done yet because only one of our faces will go through the recognition process, okay? I have index. Oh, it kind of works because if I hide my face, he's being recognized. If I don't, I'm being recognized. Okay, so it's only one person at a time. It happens because that's exactly what we wanted earlier when we focused on the only box of XY, XY. Okay, back at the time, we specifically told the model to ignore multiple faces and only focus on one. It made a lot of sense when only I was involved, but now there's a few of us, so let's fix it. So right above our coordinates, we will go ahead and fetch multiple face boxes with for box in face results boxes XY, XY. Okay, we will indent everything below it. Okay, up until our weight key, which we will not touch. Okay, and then we will replace the face results boxes XY, XY in the index of 0 with our new iteration variable of box. Okay, and now if we run our code, then each and every face box is sent through the face recognizer separately. You can tell it now because it's just me alone. Let me call Mario once again. And now my box says 0 and Mario's box says 1. So we fixed all the issues and woohoo! Yay! Yay! Finally, since people have names and not numbers, let's map the class labels to the class names. So we will create a dictionary named names, and we will map the key of 0 to Maria, as well as the key of 1 to Mario, just like we did with our labels. We will also need to set a maximum distance. Ooh. Something that separates familiar faces from strangers. So let's just say that our max distance is 70. Now, if you're looking for the absolute sweet spot, you will need some machine learning. You would have to test a whole bunch of numbers like we did in my scikit-learn tutorial. I just randomly picked 70, but you can always adjust it on your end. And same goes for our model training parameters. It's basically a naked model. We didn't change it at all. We didn't customize it, but people usually do. On our end, it just happens to work, but it can always work better. We're going to keep it for the next time, okay? So once we have our names dictionary and our maximum distance, right before we put our text, okay, right over here, we're going to check if the distance is greater than the max distance, then in this case, we are not confident enough in the identity of the person in the box. Okay, so we'll set the name to unknown. Otherwise, we will set it to whichever name the label that the model returned to us, okay, belongs to. We will do so with name equals names, okay, to which we will pass our predicted label. Okay, so names is our new dictionary, okay, and then our predicted label can only be 0 or 1. I hope I explained it clearly, okay? So then right below, when we put our text, we no longer put our predicted label, but we put the name we just derived from it, or unknown, okay? Now, if you'd like to be extra informed, we can also print the string version of the distance that we also received from the model, and we can put some kind of a separator in between. Okay, let's say this straight line. I don't know what it's called. But now when we rerun this cell, I am indeed recognized as Maria, but with a too long of a number. Okay, so let's quickly collapse it. And now let's convert our distance into an integer before we convert it into a string. Hopefully the number will be a bit smaller in terms of decimal points. And okay, I am recognized as Maria with about 50% distance. When I start covering my face, it is now 80-something distance, well above our max distance threshold, and therefore I am unknown. So now when my fingers go down, slowly, then I'm suddenly Maria again. Amazing. So now let me quickly call Mario and let's see how this thing affects it too. And congratulations, our facial recognition system is officially complete. It mostly recognizes Mario and myself. I mean, most of the time, sometimes I'm unknown because I'm talking, okay? But you can improve it by providing a little bit more photos. You can improve it by changing some of the training parameters. But for the most part, it works really well. So congratulations and yay! And thank you so much for watching. If you found this video helpful, please share it with the world. And don't forget to leave it a huge thumbs up and all kinds of comments. Now, if you'd like to see more videos of this kind, you can always subscribe to my channel and turn on the notification bell. I'll see you soon in an awesome tutorial. So in the meantime, bye-bye.